Okay, so looking at this section, the ones that I want to make sure that we focus on, square. So area of a square is side squared. So you want to take the derivative, right? So you have your equation, you take derivative, and that's implicitly, and then you plug in. And we do this every single time the exact same way. So then here, area of a rectangle. So area of a rectangle is length times width. And then remember, what we're doing is we are looking at product rule. So after I take my equation, my dA dt should be width times dL dt plus L dW dt. And then you're plugging in. Here, volume is equal to pi r squared h. So dV dt is equal to, we're going to leave pi outside, so h times 2r dr dt plus r squared dH dt. And what you're going to be like, oh man, I have too many variables, right? But remember, this is a cylindrical tank. And does the radius of the cylinder ever change? That answer is no. This represents the rate of change of the radius of the cylinder. And that is equal to 0 because that does not change. Okay? And then here, I think we're okay with this. Spherical balloon, I don't think that's an issue. That's like the one we did in class. But this was 7-1, right? Remember, Pythagorean theorem. So I'd have a squared plus b squared equals c squared. That's my first step. My second step is 2a dA dt plus 2b dB dt equals 2c dC dt. This is the rate of change of the length of the ladder. Does the length of the ladder change? No, so that's going to be equal to 0. This dB dt, the ladder is going downwards. So this dB dt in the end better be a negative value because the distance of your B is decreasing. Okay. Area is 1/2 base times height, which is A times B. So dA dt is equal to 1/2 B dA dt plus A dB dt. And then you're going to plug in. And then the last thing with this is the rate of change of theta. So 20-foot angle between the ladder and the wall, which is here. So this was my A, my B, and my C. So tangent theta is equal to A over B. And then that's my equation. And then my d theta dt is equal, times secant squared theta is equal to quotient rule. So B, dA dt minus A dB dt all over B squared. Okay, and we're solving for this. We know this by looking at the triangle because I have secant of theta would be C over B. So whatever those values are, you can plug those in. So the next thing would be to plug in. All right. And then this one follows the same thing as question 7. So that is it for this section.